Hello everyone, this is Harshita Priya and Janakar Indu of PSCB at PCM are here to explain the refractive index of liquid lens.
First, we will discuss the aim of the experiment. Aim is to determine the refractive index of a liquid by forming liquid lens using a converging lens and a plane mirror. And the apparatus required are illuminated pin, converging lens L, plane mirror M, clamp and stand, meter scale, liquid such as water, illuminated crosswire. Now we will see the apparatus. Meter scale, converging lens, plane mirror, illuminated pin, clamp and the stand. The theory of the experiment is, let us consider f1 and f2 are the focal lengths of the glass convex lens and liquid lens respectively. Let f be the focal length of their combination. Then 1 by f is equal to 1 by f1 plus 1 by f2, or 1 by f2 is equal to 1 by f minus 1 by f1. The liquid lens formed is a planar concave lens with R1 equal to R and R2 infinity. So from lens maker's formula, 1 by f2 is equals to n minus 1 into 1 by R1 minus 1 by R2. We have 1 by f2 is equal to n minus 1 by r. If r be the radius of curvature of a concave lens which is in contact with the liquid, then the refractive index of the liquid is n is equal to 1 plus r by f2, where n is the refractive index of liquid, and putting the value of f2, then n can be calculated. Now let's see the diagram of refractive index of liquid lens and the observation.
Place the mirror M and the convex lens L on a horizontal surface. Fix the needle horizontally in a clamp so that its tip is vertically above the center of the lens L. Adjust it until at some position P1 has no parallax with its inverted image. Repeat the setting of the non-parallax position twice more, and each time measure the distance from P1 to middle of L. Now we have adjusted it to some position P1 which has no parallax with its inverted image. After adjusting the point needle, move right and left to observe whether the needle and the image in the convex lens are moving in the same direction. Now we have set up the thing, and now we will measure the distance. The distance from the converging lens L and to the illuminated pin, and the distance measured in the meter scale is 11.4 centimeter. Adjust the setup for 3 more readings and get the focal length. Moisten the mirror with a little of liquid whose refractive index is to be found so that the space between lens L and the mirror M is filled with the liquid. Again we will adjust the needle until we get a non-parallax inverted image.
We adjusted the needle in such a way that the image in the converging lens and the needle are at same position, which is non-parallax position with its inverted image. Now let's measure the distance from the converging lens to the needle using a meter scale. The distance we got is around 18.5. Continue the same procedure and get 3 more readings. How to find the radius of curvature using Boy's method. The apparatus required are plane mirror, converging lens, stand, meter scale, and the source. Keep the converging lens in the stand and observe the reflection of convex lens in the source. The reflection of convex lens on the source should be clear, and it should have vertical and horizontal line.
We can now observe a clear image.
Now measure the distance from where the image is clear and take the readings.
Now place the mirror and observe the reflection, same as what we did before. Move the plane mirror and converging lens and the stand away from the light source to get a clear image. Now we got a clear image with horizontal and vertical line. Measure the distance from the source to the stand and take the distance. The distance measured from the source to the stand is around 9.5. Continue this for 3 more readings and find the radius of curvature by Boy's method. The result of the experiment is the refractive index of the liquid water is found to be 1.4311.
The learning outcomes of this experiment are: the experiment proves that the image distance and the object distance is interchanged. Experimentally, refractive index of water using liquid lens is found. Different positions of convex lens can project different orientation and size of the object. One position can make the projected image smaller or bigger and upright or upside down at the same time.